All right, this is question number 38. And it's asking you about a normally distributed population. A normally distributed population says that essentially, if there is a mean of something that's going on, okay, that essentially that it's pretty evenly weighted, the way things, literally the word normally would be. For instance, sometimes on tests, most kids score whatever, a particular score, and there are very few people that fail the test or that that make 100s. Okay, so normally distributed means that most people kind of are conglomerating close to the mean. And if you've got the mean right here, the empirical rule says this: the vast majority are within one standard deviation of the mean. In fact, there is a number to remember: 68% of I would say responses, but of the data in a normally distributed population is within one standard deviation of the mean. Okay, and in fact, you can split that two ways because the mean splits it down both sides. That would mean 34% here and 34% here. Okay. Furthermore, the empirical rule goes on to say that it is calculable how many things would be, let me get a different color, how many things would be within two standard deviations of the mean. That number is 95%. 95% of the population is within two standard deviations. Okay. And so really, if you think about it in terms of what's in the blocks, then if you take 95 and subtract the 68 that we've already used that's within one standard deviation of the mean, you will have, right, yeah, 27% for this region here and this region here, which if you split that into two, you're going to get 13.5%. Okay, so 13.5% of the data is going to live here in that little block that is greater than one standard deviation, but less than two standard deviations from the mean. Okay, and then it's almost 98%. It's 90, let me hold on, 99.7. is within three standard deviations of the mean. Okay, so if you take 99.7, subtract 95, that's 4.7%, which would be 2.35 lives here on the low end, and 2.35 lives on the high end. So this question is asking, it gives you the mean. First of all, it says the mean is 12.5. So right here, 12.5. And it tells you the standard deviation is 4.2 ounces, which means, and you're just going to add 12.5 plus 4.2, okay, would be 16.7. And then this is another standard deviation, so you're going to add another 4.2, and that would be 20.9. Okay, if you wanted to know these other numbers, you would subtract 4.2. So take away 4.2, and you would have 8.3 is the boundary of within one standard deviation. So 68% of the population of fish are between 8.3 and 16.7 ounces. Okay, and you could do it again to find these other values. So 8.3 minus 4.2 would be 4.1 ounces. But this particular question is asking you for 16.7 to 20.9, which is great because it happens to be exactly the boundaries between one standard deviation and two standard deviations of the mean. And so we've already calculated that. That number was 13.5. It said approximately, so it's about 14% of the